Okay, so I'm back, and now that we used our zeros that we had to solve for A and B, but we still need to solve for A and C, but we still need to solve for B. So this is still the first method. Actually, after we finish this, I'm gonna show you the second method to solving for your constants. But now, since you don't have any zeros, you can use any real number you want to plug into the equation to solve for B. Okay, keeping in mind, however, so this time, because we're not using one of our zeros, we need to keep in mind the values for A and C. And so my advice would be to pick the simplest number to use, which would be 0. So if 0 isn't already used, then pick 0 to evaluate. So, but again, like I said this in class, if you wanted to put in 1,000,000 for x and solve both sides and simplify, you can. You just want to make sure you keep it simple. That's my advice. Okay. So when x is equal to 0, the left-hand side of the equation, that's going to be 3 times 0 minus 9. So that's going to be -9. And the right-hand side of the equation will be, now we know that A is -2/3, right? So we'll have -2/3 times 0 plus 2, which is just going to be 2 squared, plus B times 0 minus 1, so that's -1, times 0 plus 2, which is 2, plus C, which we know is 5, times 0 minus 1, which is -1. Okay, so again, feel free to go back over this video as many times as you need to understand what we just did. Hopefully it makes sense. And so continue on, then we have -9 equals -2 times 2/3 times 4 minus 2b minus 5. Okay, we just keep simplifying this. And when you keep simplifying, so pause the video and finish simplifying, and then you should get your B. Okay, so hopefully you did pause the video to get your B, and so you found out that B actually equaled 2/3. Okay, so then that means for our final answer, the integral of 3x minus 9 over x minus 1 times x plus 2 squared is going to equal, and I'm just going to put in our value. So I'm going to simplify and break up the integral. So it's going to equal -2/3 times the integral of dx over x minus 1 plus 2/3 times the integral of dx over x plus 2 plus 5 times the integral of dx over x plus 2 squared. Don't forget that squared, okay? Okay. And again, if you need to do side work to solve these, you can. If you see it right away, you see that these are going to be, and actually I believe Anitra's asked me after class, with the linear factors. And I guess I should say, if you're having a repeated linear factor, you have to be a little more careful. But if you just have linear factors, your distinct linear factors, the integral is always going to take on the form of a natural log. Okay, so -2/3 times the natural log of the absolute value of x minus 1 plus 2/3 times the natural log of the absolute value of x plus 2. Then here, so for that last integral there, we have to do a little more work because this it's not linear, it's squared. So you need to use substitution. But once you do that, it's still pretty straightforward. So again, pause the video and finish that integration using U substitution. All right, so hopefully you paused it and came back and you realized that it's -5 over x plus 2 plus c. Okay, and that is our final answer. Okay, So I'm now going to show you another method, the other method to solve for constants. And it's just two methods. Some people put 4 methods on the homework bonus, but it's just 2. And I don't know if you hear the train in my background, but hopefully it's not too loud. Okay, so the other method. So we start actually from the step, so step 1 in the PFD is to factor the denominator, and then step 2 is to set up the PFD, and then step 3 is to solve the PFD. So this is sort of starting from step 3. So in this other method, steps 1 and 2 are are the same, and then step 3 is where they differ. Okay, and if for any chemistry majors in the class, this sort of reminds me of something we used to do in chemistry, and I'll tell you why in a minute. But the first thing we're going to do is, instead of finding zeros, we're going to distribute or multiply everything out on the right-hand side. So on the left-hand side, that's going to stay the same, but the right-hand side, we're going to multiply everything out. So that'll be x squared plus 4x plus 4 plus b times x squared plus x minus 2 plus cx minus c. Make that a little clearer. Plus c x minus c. We keep going, so, and there's a reason why I'm writing 3x minus 9 everywhere on every line instead of just putting equal signs all the way down. You'll see in a minute. So we'll have ax squared plus 4ax plus 4a plus bx squared plus bx minus 2b plus cx minus c. Okay. So we've multiplied everything through, and now what we do, we need to group together. We need to group together the like terms, okay? And so what I mean, all right, let's see. So 3x minus 9 equals, and you group them in descending order. So the largest exponent will come first, which is x squared. So we see we have an x squared here and an x squared there. And so we're factoring, but we're grouping them. And so we have a plus b x squares, okay? Because a and b are the coefficients. And so that's almost like what we're doing here, because I don't want the letters to throw you off. But what we're doing here is, if we had to say 3x plus 4x, we know that's 7x, right? But we could also say that that's 3 plus 4x, okay? And so that's all we're doing here. All right, so now finishing that. So that's x squared. So we're done with x squared. Then so x squares are good. Then we look at x, because we're going in descending order. So it's an x term there, it's an x term there, and an x term there. And we group those together. So that'll be plus 4a plus b plus c times x. Okay? And so we've taken care of our x terms. And then the remaining terms just represent our constant. So we can sort of group those together. So that's plus 4a minus 2b minus c. Okay. And then we're done with that. Okay. So now, when I say that reminds me, okay, so it reminds me of stoichiometry from chemistry. Because we have to now balance the equations. And so what I mean by that is, you're going to look at your left-hand side, and you're looking to see for each of the terms. So for x squared, how many x squared terms are on the left-hand side? For x, how many x terms are on the left-hand side? And then for your constant, what's your constant on the left-hand side? Because this is the equal sign means they're equal, right? So we can balance it. Okay. Well, notice on the left-hand side, there aren't any x squared terms. So that means this coefficient on the right-hand side, we want that to equal 0. So we want a plus b to equal 0 because there's no x squared terms. Then for x, well, there is, so that's the coefficient on the right-hand side is 4a plus b plus c. On the left-hand side, it's 3. So that means we want 4a plus b plus c to equal 3. Okay? And then for the constant term, we want that to equal negative 9. So 4a minus 2b minus c equals negative 9. And now we just need to solve these systems of equations. So that's something that you should already know how to do from algebra. But if you don't, review solving systems of equations. Also, too, I forgot to mention in class, there's a website called purplemath.com. If you've never heard of it or been on there, it's a really good website for algebra review. They have really step-by-step examples and pictures and things of that nature. But let's solve this. Okay, so I'm going to show you how to solve for one of these. We already know, keep in mind, because we just solved this, we already know what A, B, and C should be, right? So that's good. We're just making sure using this other method, we still get the same answer. And so we're going to do just one of these together, solving for one of the constants together, and then I'm going to leave the other two for you to show using this process. Or just confirm. Okay, so you can start from any of the equations you want. I'm going to start from a plus b. And I'm going to solve for a. I could solve for b, but I just want to solve for a. So a is equal to negative b. Okay, I'm going to take that information and plug it into this equation. And so then that will give me 4 times negative b plus c equals 3. And so that's negative 3b plus c equals 3. And then I'm going to solve for c. So c is equal to 3 plus 3b. And I'm going to take, now I have these two facts, and I'm going to take those two and plug it into my third equation. And so I'll have 4a is negative b, so 4 times negative b minus 2b minus c is 3 plus 3b equals negative 9. So what we just did, because we have 3 unknowns in 3 equations, which means we should be able to find all 3 of those constants, we just used the information from the first 2 equations to create that, to plug into the third equation. And now our third equation is just in terms of one variable, which is nice. All right, so if we simplify this through, then we'll have, so negative 4b minus 2b minus 3 minus 3b equals negative 9. If you simplify that, you should actually end up with negative 9b equals negative 6. And so b is going to give us 2/3, which we already knew. Okay, so I want you to finish solving for using this method, of course, and finishing using these equations to solve for a and c, which again, you already know what the values will be. Okay, and I will, which is, it's really going to be really simple. So that will be worth just a half point for doing that, because that's really straightforward. All right, and so this video is done.